Okay, welcome to session two. I'm here to introduce Chris Yest. He spent the last 20 years as a software engineer before moving into education as a curriculum author for computer science and digital literacy. His courses cover Java, C++, Python, HTML, and CSS, and other topics. Chris is currently the president of CompuScholar Incorporated. Thank you, Chris, for presenting with us today.
Sure, it's my pleasure. I'm always happy to take the opportunity to speak with folks, and hopefully today's topic will be a fun one. So we're going to talk about video game design, and in particular, we wanted to focus on the Unity IDE, which is a tool that we'll kind of cover and talk about how you might want to deploy this tool if you're interested in teaching, game design curriculum, or even if you want to use it to teach more of a standard computer science in a fun way. So I've got my screen shared here. Hopefully nothing too embarrassing will pop up, like dogs or kids here in the background as we go through. And I do encourage questions throughout, so don't be bashful about dropping something in the chat window. I'm not sure if you can unmute yourself or not, but if you can, that's perfectly fine as well. So we've covered introductions. I'm always happy to answer questions afterwards, so you can reach me at chris.yust@compuscholar.com. And what we wanted to cover today, again, just kind of talk about Unity in general and what kind of software package we're looking at. We'll cover installation and licensing, how to use that development environment. We'll talk about writing code and the ways that you can teach object-oriented programming. We'll take a look at the Unity Asset Store and talk a little bit about Nevada's digital game design standards. We'll touch very briefly on industry certifications. In full disclosure, we do have a Unity curriculum here at CompuScholar, but that's not the focus of the presentation. So I'll mention it for about 60 seconds there at the end. But my goal today is really to equip and enable you to go explore Unity on your own and select any curriculum that you want to, if that's something that you think would be of interest to you as you go forward in your teaching career. All right, so in terms of Unity itself, this is a really powerful, popular, modern game design framework. Many of today's games are written using Unity. You can deploy these games on all sorts of different platforms, from desktops to web games and consoles and different smartphones. And it's a great way to teach programming concepts. And one of the reasons that we like it is that our goal here at CompuScholar for high school students is really get them excited about computer science and get them attracted into that degree route in college. And so one of the ways to do that is to make it fun in high school. So that's a whole separate soapbox about the way sometimes we lay out our course tracks with the levels of progression and so forth, when our goal really is to get folks into college, to get them interested into computer science in college, as opposed to graduating a mini software engineer out of high school. So our goal again is just to have some fun introductory courses that will get kids excited about computer science. So in terms of the components that you'll need, there's three main components for Unity, and these are locally installed software pieces. There's the Unity Hub, which is just a centralized management tool for installing versions of the IDE and launching and creating projects and that sort of thing. The Unity IDE itself is where you and your kids will spend most of your time actually creating the games. And then when you're writing your scripts, the language for Unity is C#, and you will do that most likely with the Visual Studio Community Edition. So all three things work together, and I'll show you all of these today as we go through the presentation. So before we get too far into the nuts and bolts of how to use it, we should talk about installation and licensing. So anybody can install Unity. It's free to download and install. You do need Windows, Mac OS, and I think it supports Linux as well. So Chromebooks, obviously, you can install any software on a Chromebook, and this would certainly qualify as software that would not fit on a Chromebook. So while that installation is free, you do need to license it, and there are a couple of free options. So as long as your students are making less than $100,000 a year, they can use a free personal license. So that's pretty straightforward. And a lot of times school districts will prefer to use the Unity's educational grant. So there's an application process you can go through and fill out some paperwork, and they'll give you some free licenses that are not pinned to particular students. So from a data privacy standpoint, a lot of times districts would prefer this educational license. And that way they can just deploy that license across all the Unity installations in their computer lab and not have to worry about it on a student-by-student basis. But if a student wants to install on a home computer and work at home, they're certainly welcome to do that, and they can do that for free. All right, and I do have slides periodically to remind myself to pause and ask for questions. I don't see any in the chat window at this point, but if there's Are there any questions about the installation and licensing before we move on? Do you know if the school district allows that to be installed in the lab? Lately, everything is locked down. Even teachers can't install a lot of safe items. Yeah, so that is straight up. That's going to be something you need to figure out with your IT department. So this is locally installed software. It's no more or less dangerous than the other, third-party software you'd want to put on the computers in your lab. And so different schools and different districts will have different policies with their IT staff in terms of what can be done. So this was a direct message to me, so everybody might not have seen that question, but there was a question about what can be installed on the computer labs. So that's something that we're happy to work with your IT staff. So if they have questions about what is the software, what are the risks, what does it do, we could certainly have a conversation with them if that's something that would be helpful. All right, I don't see any other questions, so we'll move on. Okay, so let's start off talking about the Unity Hub. That was the first of those 3 software packages. There's a question came in, can we get the free license as a teacher? Absolutely. So anybody can get that free license as long as you qualify for that, less than $100,000 a year, and it's the honor system. So you just go to Unity, you follow their installation process, and you go through the process for getting the free personal license, and then you're off to the races on your local computer. All right, so the Unity Hub, again, is kind of the centralized management piece of software. And the big message here is that Unity releases new versions of their development environment all the time, like twice a year at least. And so you're constantly bombarded with prompts to upgrade your Unity IDE. And you really don't have to do that, right? Just pick a version, stick with it. All these little point revisions are just things that you can basically ignore once you get everybody onto the same platform. You will find scenarios where you and your students, maybe you're at different levels of the Unity IDE. So as long as you have a newer one than your student, you can always open up an old project in your newer version of the IDE. So I'm going to switch over here and actually show this to you. So hopefully you can see that I've popped up the Unity IDE here on my screen. And we'll click on the Installs tab first. So you can see I've got 3 different versions of the Unity IDE here that I've installed over the years. And so you can have more than one on your computer at a time. And this might be useful if you're trying to support, some weird different setups, but by and large, you can just pick one and stick with it. But if you do want to install other versions, that's where you'll do it here. Right. And so we go to projects. This is also where you'll create a new project. So you can click on new project if you want to start one, or you can open an existing project that you happen to have on your disk. And you can see a list of previously open projects here in the bottom panel. The one thing I did want to highlight is the version upgrade. So you can see I've got one here. This was a support project sent in from a student. And the version of the IDE that the student used was not the same as the one that I have installed. And so that's what this little exclamation point means. So when you click on it, it will say, hey, what do you want to do? And most likely you want to come down here and just say, upgrade this to my current version. And that way I can work with it without having to install any new software. So this is a one-time process if you happen to load up a project that was created in the older version of the IDE, and that happens all the time. It just takes a couple of minutes. And then once you've upgraded that project, you don't have to worry about it again. All right, so I think that was everything on the hub. Question that came in, will it run a Python program with the terminal console blocked, or student computers have Windows? So there's no command line access that's needed on behalf of the students. So they wouldn't run Python anyhow. This would be a C# scripting language. So they, generally speaking, do not need the terminal unlocked in order to use this. All right. So let's switch over and talk about the IDE itself. Let me see, go back to the hub and let's open up a project here. Let's just take a moment here as it comes up. It's actually spinning up on a separate window on my separate monitor here, so I'll move it over as soon as it's done. All right. So this is a really simple project, and I just wanted to use it to kind of demonstrate the IDE. I know it's going to blow it up a little bit here. So big picture, what you're looking at here is you've got on this left panel, this is called a hierarchy. And so this is the list of all the objects that you've added to the scene. So I've got 4 different alien critters here that I've added to the scene. If you click on one of your game objects, over on the right here, you've got the inspector panel. And so these different groups of things in the inspector panel are essentially objects, or components that are attached to your game object. So if you hear me using the word object quite a bit, that's because this is a very object-oriented framework, which is useful as you try and impart these object-oriented concepts to your kids. So that's your hierarchy, your game objects. If you click on the project tab down here, you can see all of the assets that you have in your project. So an asset might be a sprite, it might be a script, it could be an animation or something like that. So the assets are all down there. Let me show you. So here's a script, for example. And if we click on an alien, and I know the font's really small here in this IDE, but there's actually a component here called script, the dance script. So I've attached my dance script to this alien, and that means when I run the game, it will run that script on behalf of that object. Go ahead and run it real quick. All right, so this project is one of our earlier ones that just demonstrates, input and, responding to the keyboard and that sort of thing. So it's a pretty simple project. Just kind of talks about the input manager. All right, I've got some notes off to the side here. I'm checking just to make sure I touch all the bases on the different things. So again, you just running the game is as simple as clicking the button here, and then it'll run the game. You can stop it and pause it and that sort of thing. So coming here, it looks like a little GUI. So I'm not certain if you're talking about the IDE itself. So you can do GUI-based elements in your game, buttons and things like that if you want to. The app itself, yeah, I mean, this is a pretty traditional development environment. You can rearrange all these panels, you can move them around, close them, and that sort of thing, just like you would with Visual Studio or Eclipse or any other major development environment. All right, so let me shut this down real quick. I'm going to open up a separate project that's a little more involved. Oops. So while I'm thinking about it, in relation to the earlier question about installing in a lab, every once in a while we'll see somebody that tries to install this on a network drive, and that's a bad idea. You really want local installation, both for the development environment and for the locations where the students are saving their projects. The projects are pretty significantly cumbersome and complex on the disk. You don't have to mess with that as a student, but there's a pretty big directory structure underneath. All right, so this is a different project I just wanted to use to demonstrate some of the physics. So Unity has a very powerful physics game engine, and everything I'm showing you is 2D, by the way, but Unity at its heart is a 3D engine. So you can do all sorts of 3D games with the same level of power and complexity that you would 2D games. So game physics are controlled, again, by components on the objects. So if I click on, for example, a platform, and you can see over here on the right, I've got a collider object. So it uses collider objects to detect collisions. This rigid body puts it under the auspices of the physics engine. And then there's a hinge joint to control the way this platform moves under the physics engine. Let me just go ahead and run this real quick. Right, and so this is a project that we use just to demonstrate a lot of the different physics capabilities. So you can see I've got some invisible forces shooting up from these cones. There's a conveyor platform here that will move. Oops. There's some water with some buoyancy, right? So all this stuff is done without any code. It's just setting up the game objects appropriately on the different sprites that we put on the screen. I do have a little bit of code just to move around under control of the keyboard, but that's about it. And so you can see I've got some hinge joints here with some different levels of flexibility. So there's just a lot of cool stuff that you can do here in the IDE, and a lot of it doesn't need much coding. Let me go ahead and pull up. Wait, let me double check, make sure I've got everything I wanted to touch. Let me pick something else. Select the player here for a moment. I just wanted to highlight there's a lot of things you can do within the physics engine. So if you want to increase the mass of the player or the drag as he moves around, you can do all that right here in the inspector panel. So all these components you can set manually. You can also obviously set them under programmatic control. Right. The question came in, will it run on Wimpy 4 gig RAM laptops? The answer is probably. So the installation requirements for Unity, if you go look at Unity's website, are pretty straightforward, and they're not going to be any more impactful than running, Visual Studio itself. It is a fat app, right? It's something you have to locally install, but you don't need an Alienware desktop in order to run it successfully. The one thing you will want to watch out for, again, is just making sure you're able to do things locally on some sort of local hard drive, because as soon as you start trying to load or save things across a network drive, it's going to gum things up pretty significantly. Let's talk about collision detection for a moment. So let's go down here. So you can see on my player character, I've got a collider object. And so that, let me stop the game here real quick and blow this up so you can see it. So the box collider object, you can see a little green box around the character. So that's my collision boundary. You can do more complex colliders. You can do polygon colliders that'll adhere to the boundaries much better. So there's all sorts of different colliders here. But in terms of the game concepts, what happens is if you put collider objects or collider components on your objects, then when they bump into other objects that also have colliders on them, you'll get an event in your code. So it's a very event-driven model from a scripting or a coding perspective. You've got events that happen when you start up. In fact, let me go ahead and launch player script here. So when you want to edit scripts, you just kind of double click on one in the IDE, and that will bring up Visual Studio. And everything is object oriented again. So you're creating classes that inherit from other classes in order to do things. And then when you want to add behavior to your objects, you're essentially overriding methods. So you can add a start method if you want to do something at startup. You can add an update method if you want to do something on every clock tick. And then we've added a collision method if you want to get a callback when your sprite collides with something else in the environment. And then you can do whatever you need to respond to that collision. So that's a quick sprint through the coding and the collision detection. Pull up my notes here and just make sure I'm covering anything. So any questions about the development environment itself, just the basics of the panels and so forth? I know you've been asking them all along, which is great, but if you have any more, let me know. And so just to reiterate some of the things I said about scripts, the C# scripts are the way that you add behavior to your games. So there's plenty that you can do with the built-in physics engine, but as soon as you want to move things around or react to events, you'll start writing C# scripts. Scripts are assets, and you would attach them to a game object to run. So if we go back to the development environment and we look at the player, somewhere over here on the player inspector panel, yep, there it is, right down here, is the script that I've attached. So if you want to attach a script to an object, you just grab it and you drag it up here and you drop it on the object, and then presto, that script will work or will run on behalf of that game object. So 2 questions came in. Can you save projects externally to avoid saving on a server? I'm not certain what you mean by externally, but you would want to save projects locally on a locally attached hard drive. So you're not doing anything within a server at this point. In fact, you don't even need an internet connection, as long as the licensing will tolerate that. Can it be done on a USB or a flash drive? Possibly. It depends on the speed. Let me pull up something real quick. Just going to pull up File Explorer and come over here and show you. So this is the top level project directory for that first project I pulled up, Alien Dance Squad. And if we drill inside, you can see there's an assets folder for all of your assets. There's all sorts of internal folders that are automatically created when you build stuff, a big cache of packages, and so forth. So there's hundreds of files buried in here. And if you zip up a simple project, it might push 100 meg. right? So there's a lot of stuff here. So will things fit on a USB drive? Certainly. It comes down to the speed of operation. And that's something you certainly would want to test before you bet the farm on it. So if that's something where you've got a lab where my kids are just not going to be able to save anything to the C drive or the D drive or anything like that. You could try a mapped network share where you make a network drive look like an E drive or something like that, and then Unity wouldn't know the difference. But again, you'd want to be comfortable with the speed of that to make sure that when you load a project, the kids aren't twiddling their thumbs for 5 or 10 minutes while the project loads. And then the same thing with the USB drive, just test it out and see how it works in your local environment. There's probably a lot of variables there that I don't want to say for sure, yes or no. And while I'm thinking about it, if you're teaching this, right, and you want students to submit work, the students have a few options, or you have a few options. One is you could just go around and look at their work on their computer, right? So if they're doing all their work in the computer lab and you don't want them to have to move files anywhere, you just go look at it, when they're ready to turn it in. That might not scale too well in larger situations. So if you want students to submit files to you, what we recommend is that students basically zip up the entire project directory. So that's pretty straightforward. They just come in here, right click, send to zip file. They make a zip file of their entire project directory that incorporates all of the complexity and the mystery that's underneath that project directory without having to think about it too much. And then you can upload or move that zip file wherever you want to. In our own curriculum, we have a space where you can upload it to our system. You might prefer to have a Dropbox or a Google folder or something like that where they send things to you instead. Or they might have a shared network drive that you can get to that's part of their school-based login. So there's a lot of options for managing files, but it's something you want to think about. Okay, so I think we were talking about scripts, and we just demonstrated attaching scripts to objects in order to get those scripts to run. If you do make changes in the Unity IDE, so if you come in here and you make a change and you save it, you can build it here if you want to, that's perfectly fine, but those changes will automatically be synced back to the Unity IDE. So these things work pretty well together. You make a change in your scripts and you save it, you come back over here, it's going to reload those scripts automatically. If there are errors in your scripts, you'll actually see those here in the Unity IDE, and you can double click on those errors and it'll take you over to Visual Studio and show you the line of code where you've created the error. So that's all pretty nice and straightforward. I will point out, if you already have Visual Studio installed on your computers and you don't want to reinstall it, that's perfectly fine. Somewhere up in here, and I'm doing this on the fly, so I should have thought this through in advance, there's a way to install components. Somebody might remember it more than me. I'm not certain. It's an extension. Let's do Get Tools and Features. So we're here. Yeah, here we go. So if you've installed Visual Studio, you'll want to have the .NET desktop development environment component in there. That'll give you C# support. And if you scroll on down, you see game development with Unity. So this is the little widget that will communicate back and forth between Visual Studio and the Unity IDE. And so you just want to make sure that you have those two components installed in Visual Studio. All right, good. Occasionally, we do get questions about using a code editor other than Visual Studio, because Visual Studio itself is a pretty heavyweight package. So some folks like to use Visual Studio Code instead of Visual Studio Community Edition. So Visual Studio Code is a much more lightweight version of this. My understanding is that that's currently in beta support for Unity. So it's kind of there. If you want to take on the adventure of pulling that in and using it, you probably can. But if you run the Unity installation itself and you want to check the box for Visual Studio, the last time I checked, that was still going to give you Visual Studio Community Edition. But I suspect you can use code if you want to. You can also pick other development environments. So if you really want to use a text editor or something like that, you can do that. Let's go to File. Let's see. I'm sorry, Edit, Preferences. Click on External Tools, and then you can select the tool that you want to use when you open a script file. So that's pretty flexible. All right. Okay. I think I covered all of those topics. And again, just to kind of reiterate the object-oriented programming message, you are using C#, which itself is inherently an object-oriented programming language. The whole Unity environment makes obvious use of object-oriented concepts, from game objects to the components that you attach to them. There's inheritance and polymorphism all over the place. So whether or not you want to explain that to the kids or not is up to you, but the opportunity is certainly there. All right, so I'll take another quick pause here and see if there's any last minute questions on coding before we move on. And I'm doing a time check. I think we're doing pretty good on time, so I'm not in any rush. If anybody has any questions they want to go through, certainly let me know. Right. So as you start thinking about teaching a game design course, one of the things you'll naturally wonder about is, how do I get graphics and sounds and animations and things like that to use in my games? Because I'm not an artist, my kids might not be artists, and we certainly want them not to have to stress over that. So the curriculum you're using itself might provide those assets, or you might go get those assets on your own from a variety of places. The Unity Asset Store is a great resource. So you can see assetstore.unity.com. Let me pull that up here and switch over to it. So this is their asset store. I'm going to click on 2D because we do 2D projects ourselves. And you can come over here and filter by pricing because we want free assets, right? Everybody wants free stuff. And then you can see there's all sorts of packages here with everything from textures to platform game assets, backgrounds, full game kits. So we just pick on one at random. I'm not sure what's in here. There's a few things you'll want to pay attention to. One is a license agreement. So just click on the licenses and kind of poke through it and make sure it's okay to use in the context that you're planning on using it. Most of these free licenses certainly are intended to be used, certainly, and would be appropriate in a student setting, so that's not a problem. And we can scroll on down here, and if we click through enough, there's a way to get a preview of the contents. Let's see if I can click in here. Yep, so you can see there's a bunch of different, basically sky backgrounds here as you click through it. So you can decide if this package would be appropriate. And then if it is, go ahead and add it, and they'll download the assets into your development environment. So there's all sorts of good assets here that you can take advantage of. Right. Any questions on the assets before I move on? Very good. All right, so let's switch gears a little bit and talk about curriculum standards. So the obvious one to start with for Nevada would be the digital game development standards. Would Unity be appropriate for this and for supporting these standards? Yes, that's pretty much a no-brainer. So for any of the technical hands-on coding requirements that those standards would ask you to complete, whether it's sprites or animation or particle effects or really complicated things, Unity as a tool supports that. So the caution I have is that you'll want to look at the curriculum you're using and make sure the curriculum covers those topics that are part of your standards. And if you do look at the standards, there's actually quite a few of them that have nothing at all to do with the tool that you're using or the Unity IDE. So standards like design concepts, requirements documents, that sort of thing. Doing character development and progression and story testing, talking about industry careers, building teamwork opportunities, teaching them soft skills and professionalism, all those sorts of things obviously would be driven by the curriculum or the teacher and not necessarily the Unity IDE itself. By the same token, if you look at those standards, there's a lot of advanced topics in them. And let me see if I have a link. Yeah, so let me just go pull this up real quick. Go to our alignments page and find the digital game design. I just wanted to have a handy reference for the actual standards. So you can see the digital game design standards here on the left and the level at which they're required on the right. And so as you scroll through these, you can ask yourself, is this something that's tool-based, meaning can I do it with the Unity IDE? And if it's a technical skill, the answer is almost certainly yes. But there's plenty of things in here like explain the elements of design. Well, that's on you as the teacher or the curriculum that you choose to support. And so, and our curriculum doesn't necessarily support all these standards as well. So there's some things that we looked at and we said, that's not really appropriate for what we want to do, right? So we don't support it ourselves, but that's part of the Nevada standards. So you might have to figure out how to do that, on your own. So you can take a look at these standards if you want to. There's a lot of good food for thought here about, is this appropriate for an introductory high school student class and that sort of thing. But the big takeaway is just make sure you understand all the standards that you want to cover, and make sure you've got not only the Unity IDE, but whatever else you need in the background there to help you teach that. So on a similar topic, there are industry-based certifications that you can get for Unity. And the two most frequently pursued that we see are called their Certified User Programmer and their Certified Professional Programmer. And I have color-coded those green and red very deliberately because the user level is the one that's appropriate for high school students. And the professional level is not. The professional level is advised for people in post-secondary work to have a couple of years of experience and have already written games. And so what drives me nuts personally is I see some states that will list the professional level on their industry-based certifications list and say, we want, if your students are going to get certified in Unity, they need to be certified at the professional level, which makes no sense whatsoever because those kids can't possibly meet those standards without sacrificing their entire high school career to get there, which is not something that we would advise doing. So if you're thinking about certifications, you're thinking about adding certifications to a list in Nevada, then from a Unity perspective, this user level one is the one that they deliberately aim at high school students. So you can see all their certifications here at this link. So let's hop over and take a look at that. Sorry, I'm fighting with the Zoom here on my. There we go, Unity certifications. So we'll browse certifications. And you can see there's a lot of different levels here. So this is the user one, high school and Unity beginners, right? And so there's a couple of different flavors depending on the nature of your course. If your course is coding centric, then programmer would be the most appropriate one. If your course is really more of a design course where you dabble a little bit in coding, but you're really all about the design and the character development and the artwork, then they have a user artist that might be more appropriate. And I haven't even looked at the VR one at all, to be honest, so I'm not sure what's involved with that. And then, they go up from there. So associate, professional, and that sort of thing. And you can see post-secondary, 2 to 4 years of Unity work experience, 5+ years of Unity work experience. So really the only one that Unity at least believes is in reach of a high school student is this user level certification. So let me see if we have, I don't know if we have that up on our standards page or not. Take a quick look. Yep. So if you're curious how our course would meet the certified user standards at that high school level, you can come to our certifications page. It's standards certifications, and then click on certified user programmer to get an alignment document. And again, we cover a lot of it, but not all of it. All right. Any questions on the Unity certifications or the Nevada standards as well? All right, very good. Doing a time check. I've got about 15 minutes left. I think I'm running actually a little bit ahead of time. So let's see what else we've got here. Okay. I promise not to spend too long on the CompuScholar curriculum. So here was the 60 seconds or so, just to let you know what we have. We do have a Unity game programming course. It is aligned to those digital game design standards to some degree. You can find that at compuscholar.com/Nevada. And if any of you are interested in a free review account, I'll show you how to find that from my main website. So from our main website, compuscholar.com, click on For Classrooms, get started, and then request that review account. And that will get you into all the courses that we have, including Unity. And that's really all I wanted to say on the curriculum itself. All right, so I do have about 5 or 10 minutes of extra time because I was rushing a little bit early. So are there any questions or things that you want me to explore in more detail? I'm happy to go back into the Unity IDE and spend a little bit more time coding and that sort of thing. Question is, could these certifications be used as in-class lessons or on a student's own time? The the certifications themselves basically are taking a test, right? So I've taken a practice test myself. I didn't bother to get the real certification, but that's a 30 to 60 to 90-minute exercise with multiple choice questions. So just the act of obtaining the certification probably isn't going to entertain your kids for very long. If they're going to get certifications, then studying and preparing for those certifications is more of a long-term process that can be done in class. So hopefully, Kelly, that answered that question. Could a student do certifications on their own without any interaction from the school? Sure. Just like all certifications, it's big business and it costs money, but if the student wants to pay for and get certified, they're welcome to do that. Question came in, could you show us the parts that need to be downloaded to use Unity again? Yes, I can. Thank you for that. Let's scroll back up here. Okay, so there are 3 main parts to Unity that you would download. There's the hub, the IDE itself, and then Visual Studio. And all these really are bundled into the same installer. So when you install Unity, you're going to get the hub and Visual Studio and kind of the default current version of the IDE. It is possible to install those things separately. So you can install Visual Studio on your own and select the correct components that I showed you. So that would be back here to Visual Studio, Tools, get Tools and Features. So there's 2 things here for Visual Studio that you want. One is the .NET desktop development environment, and the other is the game development with Unity. So if you've already installed Visual Studio, you just want to add these 2 components to your current installation, that will work. If you do that manual installation, you will want to go into Unity, Edit, Preferences, select External Tools, and make sure Visual Studio is installed or selected here. It is possible that you see this Open by File extension selected. So if you've installed Visual Studio separately and your operating system understands that if a .cs file is opened, that it should launch Visual Studio, then that will kind of sort of work. But it doesn't keep the sense of the entire project. So it'll let you directly edit that source file, but it doesn't bring all the other source files into the solution. It doesn't let you set up a debugging channel, and it doesn't do that nice auto sync back and forth. So I would really recommend you avoid that Open by File extension. Instead, make sure you've got Visual Studio selected here, or whatever external script editor you've chosen for the best integration. Roger, did that cover everything okay, or was there something that I missed? I can talk about the hub as well. So this is the hub. And if you need to install separate versions of the IDE, you can do that here. Click Install Editor, and it'll give you a list of things that are available. So these are the official releases. You'll probably want to stick with those, but if you need older releases as well, you can go to their download archive and take a look at that. So what I would generally advise in terms of the versioning is just install a version. It doesn't have to be bleeding edge, but install a version that you know everybody's got access to, or maybe that your IT team has approved, and tell your kids just stick with it, right? There's no reason to try and upgrade. If you open the IDE and it prompts you to upgrade, just click no thanks, because you don't want to spend the time doing it. And you really don't want the kids to get ahead of you as a teacher, right? So if a student upgrades to a brand new version and you haven't, and starts creating projects, when they submit those projects to you, you won't be able to open them until you upgrade as a teacher, right? So to open a project, you need a version of the IDE that's at least as current as the one that was used to create the project. Okay, great. So let me see if I've got any other projects I can show you while I've got a few minutes left. Close that out. Let's see. I can load up Pinball. I haven't loaded that one in a while. So from our own perspective, we tended to stick with 2D projects as an introductory course for the same reason that in a math class, you would start off on a 2D Cartesian plane before you start talking about X, Y, and Z axis. So it's easier for the kids to get going in a 2D concept and a 2D frame of mind versus 3D. But there's plenty of 3D tutorials out there. And again, Unity at its heart is a 3D platform. So if you want to do 3D projects, you can go to that asset store and start pulling down some of the free 3D models instead of using the 2D assets. I've got the game loading here on my other monitor, so I'll flip it over. So a question about can you make scripts to connect using Python? Not to my knowledge, but I have never even considered the question before, to be honest. So I would have to go check Unity and see. Unity used to support JavaScript as a second language, and they eventually dropped that in favor of C#. And I have not heard of any plans for them to support Python within the environment, but I could just be out of date on that. So it'd probably be worth a little Google here on the side. If you have a particular interest in that or customized questions, let me real quick throw up my email address again. So chris.ust@compuscholar.com, and I'm going to drop this here in the chat window. Right, so if you've got a question where I don't have a snappy answer, I'm happy to do a little bit of research on your behalf and take a look at it, because I might learn something cool too. All right. So this is a pinball game that's just demonstrating some of the basic aspects of the physics engine. And I should have gone and looked at the project before I started, just to remind myself how it works. I don't even remember how to launch the ball anymore. Let me check the script real quick. I'll take advantage of this to, oh, that's why the script is empty. All right, so this is a bad project to load on off the cuff. I apologize for that. It was in some part of, let's take a look at Robodash, see if we can get that one working. So there's the project that I'm loading now works out. It's got a lot of animation built in, so I'll show you a little bit how the animation engine works. You can tell these projects are solid enough that, you know, even on a reasonably fast computer here, it takes a few seconds just to load them up. There you go. So this project is Robodash. Right, so stop that. So there's a lot going on here. I don't know if you could hear his music. So this project has music. So there's plenty of built-in support for sound effects and background music. As we ran the project again, you can kind of see there's some parallax effects going on. So the foreground is moving faster than the background, and that gives you some illusion of 3D, even though it's still a 2D game. If you look off to the left here, you'll see this list of objects is changing. So you can spawn new objects over time and destroy them over time. So that's part of what this project demonstrates is object management, where you're spawning these prefabs as many times as you need to. Run it again. So you can see there's one animation for the little robot man here walking. He jumps. There's a jumping animation. There's a separate firing animation. So there's a lot of really cool stuff that you can do, just kind of demonstrating, you know, all the different aspects of animation, sound effects, collision detection, object management. So this particular project, we span 2 or 3 chapters in our own curriculum just to cover all those concepts. Okay. So I think we're approaching the next session here. So I'll just kind of pause and see if anybody has any last minute questions. I won't show you anything else unless you ask for it, but I'm happy to spend an extra couple minutes here if there's something you want to see or something else you want to ask. And if not, I definitely appreciate your time. Hopefully you found it fun and entertaining, and maybe a new way to think about teaching your class. Even if you're not doing digital game design as a set of standards, you can teach all the standard coding concepts that you want to. So arrays, loops, events, object-oriented programming, inheritance, polymorphism, you can teach it all here in the context of a game design engine. And so that might be more entertaining to your kids than a console level IO kind of a vanilla Java class or a vanilla Python class that you're not able to see anything. So again, just from the perspective of making this fun for your kids and trying to get them engaged in the subject matter, just doing any sort of vanilla computer science class within the Unity framework could be a fun way to go. And I do see there's a review form down there, so I encourage you to take a look at that. I always appreciate feedback. And Carrie, if there's anything else you need to do to wrap up, let me know.
No, I would like to thank you, Chris, for sharing your expertise with us. That was very awesome. I'm definitely going to go check out Unity and try out some game design. Still semi-new to computer science, so maybe try it out. We'll see. I think I can get it though. Again, in the chat, I put the session title and a link to the forms that you'll do your evaluation. And again, make sure you do that because that counts for your attendance. And thank you again, Chris.
All right, y'all have a great day.
Any questions for me, Chris?
No, I think I'm good here on this end. I was just wrapping up and making sure there was no last minute questions that trickled into the chat, but I gave folks my email address, so hopefully they're good there.
Okay.
So I'll sign off and make way for the next crowd.
Okay, thank you so much.
Bye.
Bye. There we go.
So this is for
So-
section three.
In Novak, I am your moderator. If there's anything I can do, let me know. I think I forgot to stop recording on the last one, so I guess I better stop record and then start record.
So I am not